I've been playing around with TanStack DB and Electric SQL lately, and I'm very excited about what both of these together enable, and I kind of want to show you a little demo here. So I have a tiny demo application up here. It's a contacts management app, and I have 3 contacts, and there's 2 things I want to highlight. The first one is optimistic updates with TanStack DB. So if you change anything in that specific browser window, the UI will update immediately, not waiting for a success response from the server. And that's something that TanStack DB brings to the table. So we have 3 contacts here, and Ryan and Andy now should work at Databricks, not Neon anymore. So let me update that, Databricks. And if I click update here and we are back at the table, you see the update was immediate. There was no pending state, no loading, nothing, just super snappy, not waiting for any network route trips. So let's do the same one more time here. Bam, instant. So that's obviously really cool, right? We can delete people. Let's delete Andy real quick. And Andy gone immediately, right? Like all of that is for insert, update, and delete. And then you can see the second thing I want to highlight is that if you look at the other browser window, the changes immediately propagate without me having to refresh the page. And that is obviously real-time updates, which is nothing new, right? WebSockets, long polling, and server-side events have been around for a very long time. But that's also something now that comes with TanStack DB when you connect it with a sync engine like Electric SQL. So through one package, you now get optimistic updates and real-time updates, which is really nice because the way they implemented it is super easy to use. And that's usually the big blocker on implementing real-time and optimistic updates, especially doing it both together, just because it's not that easy to implement. And I love how it now looks in my application, how simple it is to reason about. There's one more thing though, because usually if you build something with WebSockets from scratch, right? Like you build that in your application server, you're connecting every client with via WebSockets to your web server, and then you yourself in your application logic, you have to manage events that are triggered if there's a mutation, and then it should broadcast to all connected clients, right? So you have to manage all of that yourself. And the source of truth is the application server, right? Like that's usually where you trigger the updates, at least in a naive implementation. But what's really cool here is if I jump to my database, so this is the Postgres database that is kind of the source of truth that Electric SQL connects to via logical replication. If I change anything here, let's say my Andre's email address is andre@neon.tech again. And I save this, and we go back to our applications. We can see that was immediately also updated in all UIs. So, and that is to me is like mind blowing, right? Like Postgres is the source of truth. Anytime you change anything in the database, all associated clients update, regardless of if it's a side effect, a webhook, a SQL query in an admin dashboard, right? It always will propagate to all clients because the database is really the source of truth of the sync engine. And that just simplifies everything in my mind. It just makes me very excited. All right, so let's jump into the code real quick just to see, showcase how easy it is to build this demo. So this is running on Next.js, but Next.js really doesn't play a big role here. It's just my vehicle to deploy to Vercel very easily. And then I mentioned I have a Neon database, and we have logical replication enabled. And that is important because Electric SQL requires logical replication because it tells to Postgres it acts like a logical replica. And that's how it gets any data updates from Postgres. And then in Electric SQL Cloud, we deployed a sync engine that we then connected to with TanStack DB. So there's 3 parts to this in the code. So this is just a very simple Next.js app, but we have this collections file, and that comes from TanStack DB. We create a collection, and then we use the Electric DB collection adapter to tell TanStack DB that the data, the collection we want to manage here is coming from Electric SQL. So we create this contacts or contact collection with the Electric SQL adapter. And we basically have to say where on the back end does this data live. So for that, we define and also implement an API endpoint /API/contacts. And that's basically it. So we can do some schema management here. This is a sort schema coming from my drizzle schema. So it's using sort drizzle. And then we have these callbacks for insert, update, and delete that are managing the optimistic UI updates. So you can see that TanStack has this concept of transactions. I don't want to go into that too much right now. But basically, whenever you insert, update, or delete something, you can update. You can do that as part of a transaction and update several entries at once. But here I'm doing it in a very similar manner. I just basically, every time I insert something, it's one item, same on update and same on delete. And then all we do is grab that change data and call our backend function. And in this case, those are 3 server functions. I'm just calling them, and then we have some result logic. But it's as easy as that to implement optimistic updates with TanStack, which is awesome. Cool. And then if you want to use that collection, that data, we can go to one of our components. We have this contacts list, and you can see we are importing the collection here, but also another hook from TanStack that is called use live query. So if we go here, we see the usage, and that where it becomes really interesting. So like a collection is basically a one-to-one mapping to a table, but the actual filtering would happen here. So we don't want all contacts of all users, right? And we don't want, in this case, we have some search term queries as well, right? So that's what you would usually do on a server with SQL. That is now moved to the client. So what we do here is we define the collection where we want to query from, and then we can have a where clause as well. In this case, I'm doing some search query parsing or like querying. And that will filter out the contacts that we actually want to display. And the cool thing here is that we don't have to use memo or anything like that and have to manage it in JavaScript. We can manage it, I guess it's still JavaScript, but like in the SQL-like way with TanStack. And they make sure that it doesn't trigger re-renders in a very optimized way. So this is preferred, what you should be doing when you use live query. And then all you have to do from there is render an array, right? Like this is back to just like basic React stuff. And then the optimistic updates can be triggered just by using the collection that we specified and calling delete, update, or insert on them. So super simple to do that here as well. It's just one call basically. So I really like how this looks. Very easy to work with and very much optimized, obviously, for thousands of entries. That's kind of what is the motivation behind use live query. The only other thing we have to check out is our API endpoint. So we have /API /contacts, and here we have our get request handler. And this is our proxy endpoint between TanStack and our Electric SQL sync engine server on Electric SQL Cloud. So that's what we specified in the collection, this endpoint. So what's really cool about this is, so like it uses long polling to poll updates from the sync engine, but the long polling request goes through this proxy endpoint. So we have full control over authentication authorization. And since it's just HTTP long polling, we can use our existing cookies and authentication authorization logic that we are using throughout our application. So here we can check, hey, is there a user cookie? Is the user authenticated, authorized, right? So we can do that simple logic. In this case, we're using Neon Auth, but you can use whatever authentication logic you want. And then all we have to do is kind of map the incoming request to a request to Electric SQL. So this is the URL to Electric SQL Cloud. And then we pass it our sync engine secrets, right? The source and the secret. We pass on all the query parameters that come from TanStack, right? That's how it handles the querying. So we just pass that on. But then we can do additional filters here in the proxy as well. So we can say the only table you're allowed to query here is the contacts table, nothing else. And only add to the SQL where clause the user ID. So you can only see your own contacts. So this bit here, I'm a little interested to see how this would scale in big applications if you have more complicated authorization logics, right? Like could be a little tricky to write. So I'm curious to see how that like scales. But for a simple case like this is super easy to reason about and super simple to implement and test. And then all we do is pass or like proxy that forward to the Electric SQL Sync server and return the response back to the client. So there's basically 3 files, and you have real-time updates and optimistic updates with TanStack DB and Electric SQL, having your Postgres database as the source of truth. I'm sure if it weren't for AI right now, we would be talking way more about TanStack DB and sync engines. But even for AI use cases, this is super exciting for me. If you think to these like streaming responses you're familiar with from ChatGPT, where the AI responses stream in, you could even model these kind of things with TanStack DB in a sync engine, where you just like stream it to Postgres by doing batch updates every a few milliseconds, and then it streams from Postgres through the sync engine to all clients, and you get that streaming responses across different devices. Just one example, like there's so many cool use cases where we can experiment around with TanStack DB and Electric SQL. Yeah, so I'm just super excited about this tech.